Everyone. Today we're going to discuss another interesting topic, and that is what happened before the Big Bang. For most of human history, we believed the universe had always existed. Stars, galaxies, and space itself were thought to stretch infinitely into the past. But in the early 20th century, physics changed this view dramatically. In 1929, the astronomer Edwin Hubble discovered that distant galaxies are moving away from us. The further a galaxy is, the faster it recedes. This observation revealed something extraordinary. The universe is expanding. If the universe is expanding today, then in the past it must have been smaller, denser, and hotter. When scientists run this cosmic expansion backwards, using the equation of general relativity, everything converges to an extremely dense and hot state around 13.8 billion years ago. This moment is known as the Big Bang. Importantly, the Big Bang was not an explosion in space, it was an expansion of space itself. Every region of the universe began expanding simultaneously, carrying galaxies apart as space-time stretched. But this discovery immediately raises a deeper question. If the Big Bang marks the beginning of our universe's expansion, then what happened before that? And at a first glance, the question seems natural. In everyday life, every moment has a cause and a previous moment in time. But the Big Bang challenges this intuition. According to Einstein's theory of general relativity, space and time are not separate entities. Instead, they form a single four-dimensional structure called spacetime. In the standard cosmological model, spacetime itself began expanding at the Big Bang. This leads to a surprising possibility. If time itself originated at the Big Bang, then asking what happened before may not make necessarily physical sense. A common analogy used by physicists is the North Pole. If you travel north on the Earth, you eventually reach the North Pole. But once you're there, there is no direction that is further north. Similarly, the Big Bang may represent the earliest point in time. There may simply be no earlier moment. However, the situation is not that simple. When physicists apply general relativity to the very earliest moments of the universe, the equations predict something called a singularity. At this singularity, density becomes infinite, temperature becomes infinite, and the size of the universe approaches zero. But infinites in physics usually signal that our theory has reached the limits of its validity. General relativity works extremely well for describing gravity and large-scale cosmic structures, but it does not incorporate the principles of quantum mechanics, which govern the behavior of matter and energy at extremely small scales. Near the beginning of the universe, both gravity and quantum effects become equally important. This means our current models are incomplete. To fully understand the origin of the universe, physicists need a theory of quantum gravity, a framework that successfully unifies general relativity with quantum mechanics. Several candidate theories attempt to describe this regime, and some of them suggest that the Big Bang may not have been the absolute beginning. One possibility, for example, is known as the Big Bounce. In certain models full of quantum gravity, the universe cannot compress into a true singularity. Quantum effects generate a repulsive force when densities become extremely high. Instead of collapsing into infinite density, a contracting universe reaches a minimum size and then rebounds, beginning a new phase of expansion. In this picture, the Big Bang represents a transition point between a previous contracting universe and our current expanding one. The universe may have existed long before the Big Bang, passing through cycles of contraction and expansion. Another idea comes from the theory of cosmic inflation. Inflation proposes that very shortly after the Big Bang, the universe underwent an extremely rapid period of exponential expansion. Some versions of inflation suggest that this process is eternal. So in these models, inflation continues indefinitely in the background, while small regions of space stop inflating and form individual universes. Each of these regions become what we call a bubble universe. Our observable universe would simply be one bubble among potentially countless others in a much larger cosmic structure known as the multiverse. And if this scenario is correct, then the Big Bang was not the beginning of everything. It was only the beginning of our local universe within a much larger reality. And finally, a third possibility emerges from quantum cosmology. Quantum field theory tells us that even the vacuum of empty space is not truly empty. So instead, it is filled with fluctuating fields and temporary particles that pair constantly and appear and disappear. These fluctuations are a natural consequence of the uncertainty principle. Some physicists propose that the universe itself could have originated from such a quantum fluctuation. In this view, a tiny region of space-time could spontaneously emerge due to quantum effects and then undergo rapid expansion, becoming a full universe. Although this idea is sometimes described as a universe emerging from nothing, the word nothing here refers to a quantum vacuum, which is a state governed by physical laws and quantum fields. Despite these fascinating possibilities, the truth is that we still do not have a definitive answer, and our best observations are, including measurements of the cosmic microwave background, galaxy distributions, and cosmic expansions, which all allow us to reconstruct the history of the universe back to a fraction of or a second after the Big Bang. So what happened at the very beginning, or whether there was something before that, remains one of the deepest unsolved questions in physics. Future discoveries in quantum gravity, high-energy cosmology, or observations of primordial gravitational waves may eventually reveal new clues. Until then, the origin of the universe stands as one of the most profound mysteries in science. And the answer may ultimately reshape our understanding of time, space, and reality itself. So thank you so much for listening. I hope you found it interesting. I hope that you learned something new today, and take care.